Can you guys see the screen on your screen?
Yep.
Yes.
Okay, great. And I've got SPSS loading too. All right, so go ahead then. Is it Eric?
Yeah, I don't know if it's anyone else. I don't know if I might be just reading it wrong. It was chapter 4, number 7.
Okay. This might be
Um,
the question that we have come up quite often, if it's the one that I'm thinking that it is. And actually, I'm trying to advocate to changing up some of the questions that we're using in the homework. I think they're good, but I think this one in particular does cause students some confusion. Let me look here. Okay. Chapter 4, number 7.
Yes, I have this. Yeah, I have the same question actually. I have it
Okay.
circled. So, yes.
Okay. Well, let me go ahead and give you guys just a really brief rundown of what this question is asking for. Basically, this question is just asking you to answer it theoretically. So, what would you do in this situation should you have this situation? And it is a bit confusing. Some students have said we didn't know if we had to go in and do the question before it to be able to answer the question, or we don't know what data set that they're asking for. But basically, you just want to go in and discuss theoretically or conceptually how you would handle or how you would approach this problem if you were in this situation. Does that help it make more sense?
I guess. Well, my question. That doesn't really help me. Sorry.
Okay, so that's okay.
So there's a number of people who are not coded into these two variables, num opposite, num same, and they're treated as missing values. It says, but then there is some valuable information on many individuals in the original variables of num women and num men. And then it says, those who were originally coded as NAP, not applicable, were never asked questions concerning sexual partnering.
Mm-hmm.
However, a number of respondents said they had some +1, some many, some lots. If they were never asked, how did they even answer the question? I guess I don't understand who is asked. Who said the information that they have many lots and plus? Num women or num same sex?
Well, it would be the num women, or it would be whatever variable that you're looking at to do your univariate analysis on. I mean, basically, what they're looking for you to do here, without giving away the answer, and I may be giving away the answer, but I mean, it's going to vary. The way that you treat or approach the problem is going to vary. But for example, one thing you could do is you could recode that variable, the count of the variable, into a categorical variable, either yes, no. So that could be one way to approach it, would be to just recode it or rename it. But that doesn't mean that that's the only right answer. There's a lot of different ways that you could answer that question that it would be correct. Does
Okay.
that help at all?
Yeah, I guess if they were never asked the question yet they somehow answered it.
Right. That's true. Right. So what would you?
Strange.
Sure. So this herein lies the dilemma of data cleaning, because as an analyst or as a researcher, here you are, you get this data set, and you might or might not get a code book with it that has some descriptions and some value labels. You know, as I said in the session last week, when we get these data sets in our homework examples, they're really nice, clean data sets. So, it has some of these explanations with them. But in the real world, you might get a data set where you go in and you run your univariate analysis and you find that that's not matching up. So you have this respondent who, for one variable, has been coded not applicable, but then yet another variable has an answer where you would expect there to not be an answer. So, yeah, that's the conundrum of what do you do in that instance? Because say, you have to make a judgment call as to which variable they may have answered incorrectly. Was it not applicable that was incorrect, or was it having a number in that variable that needed a number? You know what I'm saying? So you might not necessarily want to, because there could be some other valuable information in that case. One option is to just toss that entire case out of your analysis because you can't make a judgment one way or another which variable is coded correctly because you can't get back in touch with those respondents. You have no idea. But there might be other information in that case that could be valuable for you to use. So you don't want to just toss out the whole case. So then, what do you do? Do you just eliminate those two variables from the analysis, or just it's basically like a think through kind of process and try to come up with a choice that you feel like you could justify that would be reasonable for the situation?
Okay. All right, I just making sure I was understanding it properly.
Yeah. Yeah, no, I get a lot of questions every session about that particular question because it is a little confusing. So hopefully that provides some clarity.
It does.
All
Okay,
right.
thank you. Sorry, guys.
No, any other general questions?
Hi, my name is Tara Taylor. Hello, everyone.
Hi.
Hi, I had just joined the meeting, and I was having problems with uploading everything into one format, and I just want to know if when you are doing the exercises, are you doing it in the output or the syntax, or are you doing directly? Are you completing it directly in the SPSS data sets?
Yeah, there's several different ways that students are uploading information, and I'm trying to think of a way that might be most helpful to get this answer to you. One way that students do it is they take the book and they handwrite their answers on the worksheets in the book, and then they tear them out of the book and they print their SPSS output and they scan it all into one document and upload that. So that's one way to do it. Another way is students will create a Word document and do screenshots and copy and paste it into the Word document and send it. Some other students are really very savvy and do other things with merging the documents. Some students even take photos with their phone and attach them that way. The only thing that I need to see is the SPSS output and the answers to the questions in the workbook. So however you can get that together, I don't need to see your syntax or your data files or anything like that. Now, if you're having a problem with a question, it's really hard for me to help you with your analysis unless I see a syntax file, which is one of the benefits, as I explained last session, of keeping your syntax file, because if you run an analysis and something goes awry and you get an incorrect answer, I can't go back and see what might have gone wrong, because if you've just done point and click, then I can't, backtrack, or I can't audit the steps that you've taken. Where if I can eyeball your syntax file, I can say, oh, that's where the problem was. You forgot to check this box, or you forgot to do that technique, or whatever.
Okay.
But as far as, it looks like Jennifer might have a suggestion in here. She's saying that she makes copies of the pages and it looks bad because the pages are so thin that you see the other side. Sure, I can see where that would happen. So she's been retyping and copying and pasting from the output into the Word doc. Yeah, there's several different methods to the madness, and it can be a little bit cumbersome, but once you figure out a method, most students don't have any trouble with it at all. I wish I almost had an example that I could show you of what one student's look like, but I can't really do that without giving away answers to the questions. So unfortunately, I can't do that.
That's okay. At least I know I have different options. I just thought that it was only one, like you needed to see the SPS, and I wasn't able to save it in a file that was readable through the upload. That's why I was having all the problems with trying to upload it, and then I later found out that, I could use the output and it saves fine. And then, that's why I had all those saved files, as I was discovering things along the way. And so now that I'm clear on it, know how to proceed going forward, and, I'll get those to you, the ones that I did, and just have to go back and just put them in a Word file, or use one of the strategies you said I could use to
Yeah.
send them to you.
However, you can get it into as few files as possible. I mean, I don't even mind 2 files if you want to have like one file of all your a PDF file of all your scanned workbook pages, and then another file with the output. But when it starts to get to be like more than 2 files, it's really difficult for me to go in and like hunt and peck around to like try to scavenger hunt out the information. So as opposed to just not looking for the information, not being able to find it, and marking students down, if all the information is right there and easily accessible, it's much easier for me to find what it is I'm looking for.
Okay. Okay, I understand. I don't think I have screenshot on my version of Microsoft Office.
You should be able to, if you Google, go to ask the Google overlord. If you type in how do I screenshot with and type in whatever kind of computer you're using. I mentioned last week I recently got this MacBook, and so there's a huge learning curve when you move from Windows operating to a MacBook. And so these are like actually some of the questions that I had to go in and Google. I had to Google how to take a screenshot on a Mac because I didn't know. So you should be able to find the combination of key clicking to be able to screenshot if that helps. Also, in the SPSS output, you can copy and paste. And I'll actually show an example of this when we get started here with the examples tonight. I'll copy and paste an SPSS chart into Word so you can see how that happens too.
Okay. And I'm having problems in getting into the meeting. You have the meeting ID it's asking for?
You may have to go back and look at your email for when we send the email set up. But I can hear you, and I think I see that you're, well, actually, I don't see your name here listed anymore, but I can definitely hear you.
Oh, I think I see it right here. I found it on the announcements. Thank you.
You're welcome. Oh, and it looks like Jennifer just pasted it into the chat box, too, if that helps you down there. Okay, so let's go through a couple of these examples tonight. Unless anybody has any other very specific questions or very specific techniques or types of analysis that they'd like to see demonstrated, I'm just going to pick and choose from these examples. We're not going to go through all of them tonight. So the first one that we're going to do is the Chapter 3, number 4 question, and that's on page 72 of the book. And I'm getting a little feedback from somebody, so don't forget to turn off your mic while you're not speaking. And this is asking us to use our States 10 data set, and I have it right here from when we had it open last week, so I'm just going to go ahead and open it up. All right, so here's our States 10 data set. And what this question's asking us to do is it's asking us to go in and basically do some univariate analysis of all of these measures of central tendency for this particular variable, the juvenile arrest rate per 100,000 for violent crime. So this is one of those examples that you can get to this information several different ways. You can go up to analyze, you can go into descriptive statistics, you can look through frequencies, you can look through descriptives, but if you're one of those people that just wants to go by how the book does it and the examples that it has in the book, if you flip back into the beginning of the chapter there, it tells you how to go through and use this explore feature. So you can go in and you can just click on that. You can click on explore. Okay, and right now it's showing me these value labels by their acronym here or by their abbreviation. As we said, each of these variables actually has a label or has a name. You can actually go into SPSS for most types of analyses and tell SPSS to list the label here and not the acronym if that's more helpful to you. But these here are in alphabetical order, which is pretty nice because it makes it pretty easy to find the one that we need. So we can go in and we can move this over here. And then one of the ways that we can make sure everything is checked that we need to check, and I think Jennifer might have asked this question she's asking again about how to find the mode. this is one of the problems with the click menus, is that when you do the point and click menus and they change versions of SPSS, sometimes they change the little checkbox options that are available for some of these things. So we want to make sure that we have everything checked here that it might be asking us for, which I think we do. I don't think we need any of these. No, I don't think we need any of these. All right, let's see what this gives us here. All right. So yes, it is not giving us a mode, which means that there's been a change. Well, maybe not. I mean, but obviously this question here is asking you for the mode. So you're going to have to do an additional step. You're going to have to go to Analyze. And I believe if you go to Descriptives, it's not in Descriptives. It's going to be for sure in Frequencies. You can see how you can get some of the same exact information over here in Frequencies that you can get in that Explorer. So it's just it's these little checkbox, and if you write the code, if you type the code, it's really easy to plop that in there. But when you're going through the menus, you're pretty much constrained to what the menu allows you to do. So we can go in and tell it that we want all this same stuff that it's asking. It won't do, I don't know that it'll do interquartile range, but we can just see the difference in what, the frequency is going to tell us here, and there's our mode. Interestingly, here in this data set, you'll see that there is a little footnote here that multiple modes exist. So the smallest value is shown. So that's something you're going to want to pay attention to. When you have your data, we're hopeful that our data are normally relatively distributed, because there's only certain types of analyses that we can do with non-normally distributed data. When we're doing analyses, when we're doing parametric statistics, we are assuming some things about our data set. And if we violate any of those assumptions, our analysis could be incorrect. And one of those assumptions is that our data are normally distributed. So there's that normality of the data that we're moving forward with, and assuming that our data are normally distributed, which is why we have to do all this univariate analysis to begin with. But sometimes our data are not normally distributed, and that's okay. That's why we have a set of tests and procedures that fall under the category of non-parametric statistics, because if we don't have normal data, or if we have a sample size that's too small, or some other things like that, then we can do some of these other procedures with. But we can have a data set that has more than one mode. We can't really have a data set that has more than one mean or median, because if you think back to what those are, the mean is the statistical average. So you really can't have two of those. And the median is the exact middle point of your array of data. But your mode is the most frequently occurring number, and you can have more than one of those. So you can have a data set that is bimodal or even multimodal. So just, some things to keep in the back of your mind when you see a little problem like this come up. Okay, so going back to the example, now we're able to pretty much answer our question, either using this analysis that we've just done or this previous one, the Explore tab. Yeah, they're not giving us the mode up there anymore. Well, we might be able to see it here. Well, I'm going to eyeball it. All right. Yeah. Okay, so then we're going to go down to the subjective part, the subjective part of this question, and we're going to explain why we're going to use a particular measure of central tendency, or report a particular measure of central tendency, because we want to make sure that when we report the results of our data or our findings, that we're doing it in the most appropriate way. So hopefully it's sounding familiar when I say that if you have data that are not normally distributed, you're likely to have some outliers. Those are your cases that are pulling your values either left or right of the measures of central tendency. So those outliers are what's kind of messing up this normal distribution, or your bell-shaped curve that we're looking for when we're eyeballing a histogram. We have to decide what we're going to do with those. For one thing, we got to decide if we're going to keep them in our data or if we're going to exclude them and maybe use one of these trimmed means here. If we trim a mean, it can change things. But we also know that the mean, or the statistical average, is very, very sensitive to outliers. So if we're reporting a mean, we probably want to be sure that we have relatively normally distributed data. Or if we don't, we want to have a really good reason for reporting the mean as our measure of central tendency. Because it might be that our median is a more appropriate measure. For example, if you've ever heard of the term the median home value for a neighborhood, or the median family income for a city, income values or home values are usually very sensitive to being skewed by outliers, because you might have a neighborhood with, most of the homes in the $150,000 range, but you have one, $700,000 home that's in the catchment area for whatever reason. Well, that's going to really skew the average home value in that neighborhood. So that's why that median would be reported there, and there's some other examples of that in your text as well. All right, any questions about that? Okay, let's move on to chapter 4, question 1, which is on page 93 of your text. All right, so this is where we start to have some fun with SPSS. I love to do this stuff. I find it very interesting that we have this software tool available to us that we can use to look at variables and the relationships among variables in a scientific and rigorous way. And it's really a good way to put science to use in answering really important questions. So instead of just looking at means, medians, and modes, we can take all these variables that we have in our data set and we can manipulate them in other ways that might be more helpful to us. So we don't have to just stay with the variables as they are in the data set when we get them. Again, it's really important we have to know what we're doing when we start manipulating these variables, because I like to use my example of the calculator. If you take a desktop calculator and turn it on and just randomly type in 15 numbers and then hit plus and hit 3 numbers and hit minus, minus, minus numbers, divide numbers, it's going to spit you out something on the little screen. So it's garbage in, garbage out. It's not meaningful information. It's just a bunch of stuff you've plopped in there because it's a computer and it's going to spit something out. So SPSS works the same way. You have to know, and you have to give a lot of thought, and you have to have a high level of confidence that what you're doing in SPSS, you're doing correctly. Because if not, it's going to spit you out a bunch of numbers that don't mean anything, that are indecipherable, or that are just completely inaccurate and wrong, and then you're going to go to report your findings and they're going to be completely inaccurate and wrong, and that's not good for anybody. So we want to be sure what we're doing with these variables is correct, is accurate. So this example is asking us to create a new variable. So when we've gotten our data set over here, we have these variables and all these variables up here, okay? And so what we're going to do with this next one is we're going to create a new variable over here. Now, obviously, we're not going to go out and ask all of our respondents again. I mean, potentially we could if we have access to them, if it wasn't anonymous or confidential data and we had the time and energy to do that. But perhaps we don't have to. Maybe we can calculate the variable that we're interested in knowing from the information that we already have. So we're going to make our whole own new variable. And we're going to go into Transform, Compute. And there's a lot of different ways we can go about this, but basically we're going to rename our new variable, and we want to know murders as a percentage of violent crimes. So we already know murders and we already know violent crimes. That information is already contained in our data set. But we want to compute a percentage of that for whatever reason. That's going to help us answer our question or provide information. So our new variable that we're going to create is murd PCT. So it's already told us what it wants us to name it. And then we can click this type and label. Okay, and it's telling us to label it murders as a percentage of violent crimes. And this might start to make more sense to you of why we run this in syntax, because you're going to go through, several steps here, and say you need to change one little teeny thing in this and rerun it. You may not want to have to go through, you might not remember all of these different point and click steps you took, but if you have your syntax, you'll be able to do that. We need to tell it it's a numeric because it's going to be a percentage. Okay. Now, what we're going to do is we are going to choose our variables that we're going to use. Again, there's different ways to do this. You can either type them in yourself, such as this, CRS 37 divided by, or if you're the point and click type and you want to move that over, okay, you can do it that way. You can type in the asterisk, or you can use this one here. Make sure you got your end parens in there. That's the one thing about typing code, is you have to be very precise about your characters. And there we go. So this is a pretty simple example. We're not going to use any of these functions. They have these if, then. If you only want certain cases in the equation, you can use this. So this is the beauty of this program, is it's very sophisticated and do a lot of things that you might want it to do. So we'll go ahead, we'll paste it in just for the heck of it. And so this is what it looks like in the syntax. And then we'll run it from here. And now we're not really going to get an output because all we've done is created a new variable, but we can check our output to make sure we don't have some big error message that we've written something wrong in here. So we don't have an error message in our output, so it looks pretty good. It looks like our new variable has been created successfully. We can double check that by going back over into our variable view. And, oh, I'm sorry, yep, we can go back into our variable view and scroll all the way down to the bottom and see here that there is our new variable that we've created. So yay, we did it. And we can also even go into the data view and scroll all the way to the end and just eyeball it and make sure it looks like we've got some values that fit our equation. If we had giant values in here or something, it might not fit. So then what we're going to do is it's asking us what is the mean, the state with the highest percentage, lowest percentage, etc. So now all we have to do is just go in, and however it is that you want to get at your information, you can get at your information. Didn't put it at the bottom. There it is. Okay, we'll just, too much information isn't a bad thing sometimes. And we'll just click on that and see what SPSS has to tell us. So here is our frequencies. Okay. Now I also mentioned that I wanted to show a demonstration of how to pull this in. Sorry, this is some of my research here, so don't mind this. I'm just going to open a new blank document. All right. So you can do a copy and a paste. There we go. So that's one way to pull your information over. And then you can, type in the answers that you're writing in the workbook. There's several different ways to do it. All right. Okay. Let's go through Let's move on to chapter 5. Chapter 5 is when we start talking about bivariate analysis. So we've done a lot of work to become familiar with each individual variable on their own, and we feel comfortable with the characteristics of each individual variable. So we've looked at their measures of central tendency, dispersion, looked for the normality of the data, all those things. We looked for missingness. We've made sure we don't have lots of outliers or funky cases in there that say not applicable for one answer, but then they have, a number plugged in for another answer. And we've recoded and we've decided what we're going to do with all these funky cases that might be throwing our data off. This is probably the most time-intensive process, is coming up to when you actually start looking at the relationships between the two variables. That's actually, it's still time-intensive, but I feel like the data cleaning and the univariate analysis is actually the more laborious part of the data analytics. So now that we've gotten our data all cleaned up and ready to go, we can go in and we can look at the relationship between two or potentially more. We want to move to multivariate analyses. So if we go to chapter 5, question 1, actually I think that one is in that one might be the one that's in your homework. Can't remember that one, but that one's just, again, more of a conceptual question. So you won't necessarily need to do any SPSS analysis to answer that question, but you're going to need to have a good working understanding of what a significance value is and how to apply it. Does everyone feel comfortable with that? All right. Okay, let's move on to chapter 5, question 4. I like to make sure that I cover this one because this one is using crosstabs and chi-square, and that's a very common type of analysis that's done in the social and educational sciences. So if you're reading in your journal articles, or if you're reading in your professional articles at your job, or you're reading, the news that might be reporting some studies been done, many of the studies' findings are using this type of analysis. It's relatively simple. It's robust. You can do this with this is a type of non-parametric statistics. So if you have some violations of the important assumptions of your data, you can still use this type of analysis. So it's very handy. And it uses a matrix, or it uses a chart that you can display that is pretty understandable to anybody who's comfortable reading and comparing percentages. And so not only do we use the crosstabs to make a display and eyeball and compare the information, but there's also this statistical test known as the chi-square that's also associated with it. So we can look for the test and we can look for that significance threshold to determine whether or not only are there differences in our data, but are there significant differences? Did our findings reach significance, which is very important. So this one's asking us to use our other data set. Let's go in and open that up. All right, here we go. I'm going to close out my other data set just because I don't need it and I don't want to get confused. I'm not going to save it. You can if you want, if you're saving to your desktop or anything like that. For this analysis, I don't end up saving this. No. All right, so we're going to open our GSS08. And what this is looking at is it's examining the relationship between race and whether a person supports the death penalty for murder. So we have those two variables contained in our data set here. We know if our respondents supported the death penalty, and we also know their race. So we've already gone in and we've done our univariate statistics, a univariate analysis on both of those variables. So we know that both the race variable and the CAP-PUN variable are clean and that we're ready to look at the relationship of those two variables together. So we can look at their relationship a few ways, look at correlation, some other things, but we've decided that we're going to use crosstab and we're going to use chi-square analysis to look at the relationship between these two variables. And the first part of this question is asking for us to make a prediction. So as scientists often do, where maybe we have a hypothesis that we've gleaned from the literature, or maybe we have some practice wisdom or professional wisdom that we've gleaned. And so we're going to make a prediction about what % of Americans support the death penalty. And then also whether or not we think, and now this is just our personal opinion, so it's not right or wrong, it's just an opinion, although we shouldn't base a scientific hypothesis on our personal opinion. Those are two different things. A scientific hypothesis, or a hypothesis for a properly specified hypothesis for a research study, is very well rooted in the empirical literature. So that's one of the points of doing a literature review, is so we find out what is known and what might be unknown to that point about our questions, about our topic. So it's a hypothesis is more than just merely an educated guess. A lot of people will define a hypothesis as an educated guess, but a hypothesis is a lot more sophisticated than an educated guess. It's measurable, it's observable, it's quantifiable when you're looking at quantitative statistics. So it goes a little bit further, but not to get too off track there. So this is just our opinion here, not necessarily a hypothesis. But now we're going to use our SPSS analysis to answer some of these questions. We're going to go back up here to analyze, and it's crosstabs is still up here in descriptive statistics. So as you guys can see, there's so many more other types of analyses that you can run that I don't even believe we get into in this class. You may get into some of the linear models in the next class, but for tonight, we're just going to focus on the crosstabs. And then you're going to drag in your variables. So what I like to do, the way that this arranges it, is it's going to plop it into your output. And if you have a variable with a lot of response choices, I would put that variable in the column. So that way it runs downward on your page as opposed to outward to the right, and where it's making it dragging it off the page and you can't print it, or you try to print it and you get 15 pages of indiscernible stuff. But otherwise, the row and the column really don't matter. They're totally interchangeable. You can put your either variable you want either way. So I know that for race, I probably have like 4 or 5 response choices. It can be white, black, whatever the Latino, Hispanic, whatever the response choices are. And then I know for CapPun, it's probably a yes or no question. So for me, just to make it easier, I would put the ones with the shorter. I'm going to put CapPun in my row. Oh, I'm sorry, in my column, and race in my row. But yet again, that's just my quirky way that I like to do my data analysis. It doesn't mean you have to do it that way. So there's a lot of different other options you can click here. You're going to want to check out. This is yet again another example of how sophisticated this statistic stuff is, because we can do all these different types of analyses if we need to, and that would be driven by what might be going on in our data. But for this, all we really want is we want that chi-square test. We want to tell it to run the chi-square test for significance on this cross tabulation. Now over here is also where you can tell it to do some other things. Hopefully you've become comfortable with what the chi-square test does, what crosstabs does, and you know that basically what the cross tabulation does is it comes up with the observed values, or it lists the observed values that are actually reported in your data, and then it generates this theoretical, this mathematical expected value. Okay, so in your data, what it's looking for is significance, or it's looking for the relationships between these two variables. And what the crosstab is going to tell you is it's going to tell you the observed value, or the one that's been reported by your respondents, and then also this theoretical mathematical expected value. So if you're interested, you can look at them both. But if you just, like I said, this chart's going to start to get kind of a lot of information in it really quick. So if you don't want to get confused, you don't have to click these, or you can do it one way, and if you don't like it, you can take it out and run it another way. In addition, if you're looking at the z-test or the residuals, you can click for that, but this might be an example where it will be information overload, where you want to keep all that out unless you're being specifically asked or specifically interested in it. I like to know the percentages, just because when you're reporting, a lot of people will report percentages in research findings. And so I'll just have SPSS do it for me by clicking those. All right, I think we're ready to spin the wheel here and find out what we've gotten. All right, so here's our crosstab, and it's telling us it's a matrix, and it's breaking our respondents down by race over here and who favors or opposes the death penalty up here. So it's giving us a count, okay? And then it's also giving us the expected count, which what that means is that's what the math says would be expected in this data, right? And so what the chi-square test does is it compares the real count to the expected count. And if it's different, that's when you're going to find out if you've reached significance or not. Again, that's not really important. It's an aside, but it's just information that I like to see. So we can eyeball here and we can see that 28% of white individuals oppose the death penalty, whereas 66% favor. And you can go through and look at these for each of your responses all the way down. So it looks like for our race, we just had white, black, or other. So it really wouldn't have mattered if you flipped this matrix and put the columns up here and the rows down here. All right, and if we needed to report percentages for our project, boom, here we go. They're right there. All right, now what we're going to look at to determine if our study has reached significance is this chi-square test. So this chart is the crosstab. Okay, and this is just information that you can eyeball, but you can't tell. We can see that there's a difference between those that oppose and favor. So we can see that there's a difference because the percentages are different. But what we want to know as researchers and as statisticians is there a significant difference between these two? Is our data such that it is not up to chance or error that's occurring in our data, that there is a difference? And that's why we have set that p-value at 0.05. It talks about that in your book. So if we come down here, we can see that our chi-square value, our actual chi-square value, if you were asked to report it, would be that right there, 71.95. Okay, and then our significance, our two-tailed or two-sided significance, is very small. It's 0.000. So if you had set your significance threshold at 0.05, this test would have reached significance because it is smaller than 0.05. And it's probably really small. SPSS truncates this. Sometimes you can get in there and look and see what it is. There, that's how small it is, that it's in some crazy scientific notation. But we don't need to know that. All we need to know is that it is smaller than 0.05. All right. Any questions on that? Okay, chapter 5, question 6 is the exact same type of question. It's looking at chi-square analysis. So unless you specifically want me to go through it step by step again, I won't keep you any longer, but feel free if you have any specific questions, concerns, or comments to go ahead and ask them at this time. All right, everyone. Well, thank you for your time this evening. And if you have any questions or concerns, please do email me at my personal email address. For some reason, even my personal email address strongly dislikes emails from Indiana Tech server, and I have to go fish them out of my junk mailbox, even though I've tried to put Indiana Tech on my safe senders list. But please do send me an email and I will try to respond to you. If you haven't heard from me within 24 to 48 hours, it's not a bad idea to try to re-email just in case I haven't received it. I wish there was a better way to get in touch, but I think that since we're on the online environment, we're at the mercy of the technology system, and sometimes things don't work exactly the way that we had hoped them to. But I will respond as soon as I can. And unmuted. Wow, I'm just got a lot of feedback. I'm sorry. Unmuted. Wow. Okay. I'm sorry. The audio is kind of freaking out on us, but we're done. So thank you all very much. Have a good evening, and your grades are posted for the last homework. So take a look, and if you have any questions, let me know.